Chizuzo, and I'm going to be presenting about the software development fundamentals. I am a computer science student at DMI in 4th year, finalizing this year. So I'm about to start presenting on the software development fundamentals. I've been doing this for 6 years right now, and I can say I'm a bit, I understand software development in the C family languages, which are object-oriented languages, C, C++, and C#, but especially C#, that's what I've been doing for years. So today we are going to see things which are in the purpose of our presentations. We have understanding the meaning of software development. What is a software language? Why do we need specific software languages? And we are going to look at the object-oriented programming. And specifically, we are going to touch on the C family in certain OOP languages. So that's the purpose of our presentation. So after these presentations, we are going to have a clear picture on these things that are on our screen right now. So what is software development? So software development, it refers to a set of computer science activities that dedicated to create, design, deploy, and support a software after the software has been created already. So to create a software, we need what we call an IDE, or an integrated development environment software. And I hope some of us, if we've been trying to code, we've seen some of them, and some of them are here on the screen, which are Visual Studio, Eclipse, we have Juno IDE, we have Xcode, Cloud9, and Android Studio for Android developers. And then there's also NetBeans for the Java developers. So an integrated development environment, or the IDE, it's a software applications that provides comprehensive facilities for software development, which means that these are the applications, these are software that are used to create other softwares. You understand? So that's simply a simple definition of an IDE, a software that is used to create and then facilitate another software development. So that's the IDE. And then now we are going to see why do we need different software languages. So the programming languages, there are certain things that are required. There are certain things that are required when creating an application, or when trying to understand or trying to see what you want to create. Like, you have to put in mind certain things, and those some of those things are called there's abstractions, there's domain specific requirements, there's performance optimization, community ecosystem, platform compatibility, and paradigm sustainability. These are the things that we have to keep in mind before we start creating an application, and when we choose a language that we have to use to create an application. So if we look at the abstraction, programming languages, it provides higher levels of abstractions that allow developers to express the complexity of their application, or what type of level is the program going to be. A low level like the C language or assembly language that provides simple control over hardware, or is it going to be a high language as Python, C# or JavaScript? So that's one of the things that you have to put in mind when you're trying to create a program. And then it has to be there is also domain specific requirements, because certain programming languages are designed to address specific domains. Like, there is SQL, which is used to manage query databases, and then MATLAB, which is used for specific scientific computing. It's one of the most used languages these days, for people doing statistical analysis. So there are some other domain-specific languages that are tailored by the needs and constraints of certain respective areas, such as offering specialized libraries, syntax, and tools. Because in C Sharp, you might find that there's certain libraries that are available in C Sharp that are not available in JavaScript or not available in some other languages. So when you're trying to choose a language to create a program with, you have to put those things in consideration. You have to look at what type of syntax, how is the syntax, what type of libraries are available, and what type of tools are available. So that plays in hand. So performance optimization. Different programming languages have varying levels of performances and efficiency. So low-level languages such as C and C++ allow developers to write the code with fine-grained control over system resources and enabling high optimized and efficient programs in contrast, high-level languages often prioritize productivity and ease of use. So if you are creating an application, most of the times, like for new beginners or people who are still dipping their toes into software development, you will find that languages such as C and C++ are harder to understand than languages like Java and C Sharp, because high-level languages, most of the times, because they prioritize productivity, they make it easy to use for developers. But C and C++, you might find that there are certain things that uh, are very hard to understand, such as pointers. The pointers concept, like it's one of the hardest things for programmers to understand, and it only exists in the C and C++ languages. So those are the things that people have to look at. And then the community and ecosystem. Programming languages foster communities of developers who contribute to libraries, frameworks, and tools specific to languages. This ecosystem provides the wealth of resources, support, and shared knowledge. I can give an example on the community. As if we look at the operating systems, like the two operating systems such as iOS and Android, if you look at the Android community, you find that it has more applications because the Android gives a lot of flexibility to developers to create multiple applications and be able to access resources, whereby they can create multiple things, like as creating modes for applications like WhatsApp. If you see WhatsApp, you might find that there is WhatsApp GP. It's a mode of an already existing application. So there is a community of moders that take the already existing application, because most of the Android developers, they share the code and then they build on that. But it doesn't exist on the iOS because it doesn't have a good community of developers that develop multiple applications. So by using a popular language, developers can leverage existing communities in an ecosystem for making development more efficient and accelerating their projects, which means that if I'm going to use JavaScript, because JavaScript has been there for a long time than these other languages, or it has a bigger community than some other languages such as C Sharp, you might find that there are a lot of libraries that exist. You might find that there is a lot of libraries that exist right there for the community or other developers to access. So that's one of the reasons why choosing a community in a certain ecosystem is super important when you are trying to choose a software language that you are creating your application with. So platform compatibility. Some programming languages are designed to target specific platforms and environments. For example, Java is write once, run anywhere. It has a write once, write anywhere, run anywhere principle, and can be executed on any platform with a Java virtual machine. And then Swift and Object-C are also used in developing applications on Apple iOS and macOS platform. It means that if you want to create an application, you have to make sure that it's compatible with a certain platform that you are trying to target or the platform that you need. So that's one of the things that you have to look at. I was just checking the questions. Okay, so and then the platform compatibility too. You find that like there are certain platforms that require high end computers, or certain languages that require high end computers because of maybe the IDE that you are using. Like most of the computers that use Visual Studio, like Visual Studio 2019, to run maybe Java or C Sharp, you might find that you will need a high end computer to do that. So that plays also a role in that. And then paradigms of sustainability. Different programming languages support different programming paradigms such as procedural, object-oriented, functional, or declarative. The choice of a language depends on the paradigm that best matches the problem at hand, which means that you can choose something which is different from something that you are already looking for. Like for instance, an object-oriented language such as Java or C Sharp are well suited for building large-scale applications with complex object hierarchies and relationships. You can't use them for simple applications that do simple basic things, because it's going to take you a lot of time. It's going to take you a lot of time, and it might take a lot of space if you are using less resources. So you also have to put the paradigm sustainability in consideration when you're trying to create a program with a specific software language. So next, so now here are the various programming languages that we have. We have the C family, which is C, C++, and C Sharp. We have Java, we have Python, we have Visual Basic, JavaScript, PHP, SQL, and Scratch. So one of the mostly used languages, like mostly used languages by big corporations these days, it's C Sharp. Like most of the C family, actually, they use the C family in some of the higher corporations because C is used mostly for robotics and assembly type of applications, or plus C++ and C Sharp for object-oriented programming applications, but also Java. But Java is becoming a little bit less popular, and then Python is also still being used these days. And then there is also Visual Basics for the people that are still like starting in computer programming. Visual Basics is actually like C Sharp, but C Sharp, which is in words. It's like typed in words, it's for beginners. And then JavaScript, which is also like Java, but works with the HTML and when you're trying to create websites. So JavaScript and PHP, they're almost the same. They work with websites, and SQL for databases. And then Scratch, which is used mostly for creating robotic applications, especially with the MIT guys, the MIT University guys. That's the language that they use when they are trying to create AI-based applications. So let's go with the C family. So C, it's general purpose procedural programming language created by Dennis Ritchie in the 1970s. It's known for its simplicity, it's efficient, and it's a low-level system access, and became popular due to its portability, and it writes high-performance code. And it has influenced the development of many other languages in the C family because it's the first C family language to ever exist. So the C++ and C Sharp all came from the C language. So C++ is an extension of the C language that introduced the concept of object-oriented programming, the OOP. It was developed in the 1980s, and it added features like classes, inheritance, polymorphism to the C language. So it added the object-oriented programming Uh, and it makes it suitable for larger scale software development. If you want a program that does multiple stuffs, you have to use the C++ instead of C, because C will require to write a large amount of codes and it doesn't have certain concepts that exist in there. So making it suitable to create large scale software. And then it combines the power of low level programming with the higher level abstractions. And it has become one of the most widely used languages. Until this date, people still use the C++ languages, even more sometimes than Java. So C Sharp, it was introduced in the 2000s by Microsoft, and it was inspired by C++. And then it was also inspired by Java because it's almost the same. Uh, Specifically, the C Sharp, because it's an object-oriented programming. Most of the object-oriented programming of the class and provides a simplified and safer programming model, and it has gained uh, for developing Windows applications, web services, and game development using Unity engine. So one of the biggest roles and one of the biggest advantages of C Sharp is that uh, it's used to create multiple things, because you can create a website using C Sharp. You can create a website using C Sharp with ASP.NET. You can create games using Unity with C Sharp. You can create web services, and it has become a little bit more popular to create applications using the Xamarin. So Xamarin um, creates applications, uh, multiple applications, like from mobile apps in iOS, mobile apps in Android, and mobile apps in UWP, which is Windows phones and PCs. So that's one of the importance of using C Sharp, because it gives you access to creating applications. You just write a single code and it makes it available, creates an application that works in three forms. So that's one of the most importance of this language. So C is a subset of C++ that provides a more restricted and minimalistic feature set, and it's used in situations where code efficiency and minimal runtime overhead, which means that it's fast and are critical, such as embedded systems and operating system development. Now, when we are creating an operating system and an embedded system, it means that the main thing that we are going to be looking at is the speed and the efficiency of the system itself. So that's the reason why they use C, the C language, because it has a minimal feature set and it's super fast and reliable. So it also serves as a common language for interoperability with other programming languages. So that's one of the most important things that C can do. So if we look at the Java and JavaScript, uh, it's a high level general purpose programming, and it was invented in the 90s. Uh, it's known for its platform independence, meaning that the Java program can run on any device or operating system with a JVM or Java virtual machine, as I said before. So Java follows the principle of write once, run anywhere, and makes it popular for building cross-platform applications. Cross-platform applications are the Android, iOS, and the UWP application, meaning you write a code in a single line of code, and it works in three different forms. You extract a single APK and it works in three different forms with three different platforms. So it's an object-oriented language emphasizing on classes, objects, and inheritance. So as I said before, classes, objects, inheritance, it has polymorphism, and I'm going to explain what those things mean as we move forward. So it offers automatic memory management through garbage collection, which simplifies the memory management for developers. Garbage collection is one of the most important features because if the garbage isn't being collected, it means that it consumes a lot of memory when you are creating an application, and that is very, very, very critical for the performance of a person when they are creating an application using the IDE. It has a large and active community with vast ecosystem and libraries, frameworks, and tools to facilitate application development because it's been there for a long time and it's been popular for a long time. It has a large community that is always enhancing and creating more libraries for people to use. So Java is widely used for the development enterprise level applications, Android mobile apps, server-side applications, and large-scale distributed systems. These are one of the things that you can do with this language of Java. So if you go with JavaScript, it's also a high-level interpreted programming language primarily used for the client-side web development. This is used for web development instead of Java and JavaScript are a little bit different. So it was created also in the mid-90s, and it evolved into a versatile language used for various contexts beyond the web browsers. So it's often referred to as the language of the web, as it allows dynamic interactivity and manipulation of web page contents. So it's used like when we create websites using the HTML language or HTML, that's a static website. So for it to make it dynamic and being able to interact with the person, like asking data from person, and then using that data on the server, JavaScript allows us to do that dynamically. And it's primarily used to enhance the web page by providing functionality such as form of validation, animation, and dynamic content updates. When you look at the websites, like most of the times you might find that, okay, like on YouTube, they give you a capability of adding a new video whenever you want to add it. So dynamically adding that new video, we use JavaScript. JavaScript is used to make that happen, to update the content on the website for it not to remain static with the same information. Because if it's remained static, then it's going to be like a book, which is going to be there each and every time. But the more we update, the more dynamic it gets. And that's how it becomes user-friendly because people can be seeing different things each and every time. So JavaScript it's event-driven. It enables response to user actions or even triggered by the browser, which means that when you click on a video, it plays the video. You can pause the video, move it. You can type a comment. That's what we call it event-driven, which means that if we have an event or an action of clicking a button, something has to happen. So that's what they mean by event-driven. With the rise of Node.js, JavaScript has also become a popular server-side for language building, scalable and performant web applications. So it doesn't only work on the client side, but with the use of Node.js or Node JavaScript, it's also popular. It's also becoming popular these days by creating apps that can perform also on the server side. And it has a vast ecosystem of framework and libraries like React, Angular, Express.js, which facilitate the front end and the back end development of a website. While Java and JavaScript share a similar name, they're actually distinct languages with different use cases. Java is more focused on building enterprise applications or these apps that we have in our phones like WhatsApp, Facebook, simple apps like Telegram, while JavaScript is primarily used for web development on both web server side and client side. So that's the basic difference between Java and JavaScript. They might have the same name, but they're different. So let's look at the OOP, or object-oriented programming. What does it mean? And before I proceed, I want to ask you guys if I want to ask you guys if the sound is okay before I proceed, because I don't know if you guys are catching up. So if the sound is okay, like, you can let me know, and then we can proceed. Can somebody please let me know if everything is okay? If the presentation is going well, somebody. Okay. So yeah, let's proceed. So object-oriented programming. So this is a programming paradigm that organizes the code around objects, which are instances of classes. And then here are some of the short notes on this. So the object-oriented programming, like, it has the concept of objects and classes, because we are talking about object-oriented programming. So the objects are the fundamental building of blocks of OOP, and they encapsulate data, or the attributes, the data attributes, and then behaviors, or the methods. So when we talk about the data, we are talking about the data attributes, which are going to be having data in them, and we have behaviors, which are methods that perform specific tasks, so into a single entity. So objects, they have both those things as a single entity. So the classes serve as a blueprint. I don't know if you understand the blueprint. A blueprint is like the foundation, or the base, or the template of creating an object. So they define the structure, the attributes, the behaviors that those objects are going to have in the class. So that's basically what the objects and classes are in the object-oriented programming. So there is an encapsulation. I've been saying this word over and over again. So encapsulation, this is the process of bundling data and related methods together within an object, hiding the internal implementation details from the outside. This ensures that the object's internal state is accessed and modified through a well-defined interface, promoting integrity and the security of the data that you are having. So this encapsulation, the examples, you might find that there is public, private, there is protected. So you specified that depending on how the data in your objects are going to be accessed throughout the application. And this is going to be a very, 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 very important concept as you move on with software development career, coding with OOP languages, object-oriented programming languages. There is also inheritance. So inheritance allows classes to inherit the properties, behaviors of other classes, establishing hierarchical relationship. The derived class or a subclass can extend or override the functionality of the base class, which is a superclass. Inheritance promotes the code reuse and enables the creation of specialized classes based on the more general ones. So when I was starting, like, with my coding career, I used to create a program, because I started with Java and then went to C#. So they used to tell me that the cleaner the code looks, the more professional it looks, and that's how people are going to be judging you as a programmer, by looking at your code. So if you put the codes together in one class, it's going to look horrible. So you have to use multiple classes and use the inheritance in order to make your code look clean. The more classes you use, the simpler the code gets, and the cleaner and the more professional your code looks. So this is one of the most important concepts too that you have to follow to make your code simple, make it easy for other people to use. Because when we are talking about libraries, those are classes that are put together for people to use. So Other people may use your libraries in the future, or you can also reuse them if you want. So there's also polymorphism that allows objects of different classes to be treated as the objects of a common superclass. It enables the use of a single interface to represent different types of objects, providing the flexibility and extensibility of the code. Polymorphism is often achieved through method overriding and method overloading. We are going to discuss about this a little bit later. So abstraction. So abstraction involves the representing essential feature of an object or a system while hiding unnecessary details. It focuses on capturing the core characteristics and behaviors of relevant and problem of the domain to the domain. Abstraction simplifies the complexity of a system, allowing developers to focus on essential concepts of irrelevant details. So when we look at the certain systems, you might find that behind those systems, there is a lot of codes that we don't understand because they might be based on the architecture of the system. So most of the times we don't want to touch certain things that we don't know what they do. So that's the reason why they abstract them and focus on the most important stuff. Like if you want to see in a system, there are certain classes that are built in. So those built-in classes, they are abstracted. Why? Because we don't have to understand them. We just know that we have to use them at a specific time for a specific task. So we just call them. Like the string class, there is a lot of code behind it. So it's an essential feature, but it's unnecessary to look at the details behind it. We just have to understand how it works and then its behavior. So we call it and use it without seeing what's behind it. So that's what abstraction means. And then association and composition. Association represents the relationship between two or more objects where each object maintains the reference to the other. Composition is a form of association where one class is composed of one or more instances of the other class. These relationships allows the objects to collaborate and interact with each other to accomplish certain tasks. I hope this like explains itself. And then there is object-oriented analysis and design. It's a process of analyzing, designing, and modeling a software system using an object-oriented principle and technique. It involves identifying objects, their attributes, the relationships, and the behavior, and creating models such as class diagrams and sequence diagrams to represent the system structure and interaction. And this just deals with the analysis and designs of the app that focuses on the object-oriented thing. And object-oriented programming now provides a modular, reusable, maintainable approach to software development. So the reason why object-oriented programming was developed, because as I was explaining with the languages, I started with C. So when C, during the evolution of C, when it became C++, they introduced certain object-oriented programming concepts. They wanted to make it more reusable. They wanted to make it more reusable. Instead of retyping the codes that you had, you can reuse the existing code and then maintain the approach to the software development. And it promotes the code organization through encapsulation, which means that we are creating more classes, we are creating more methods, we are creating more functions and abstractions, hiding unnecessary stuff. And it leads to a more understandable and flexible code. Now, the reason why many people don't start creating applications using C is because it doesn't like use certain object-oriented programming concepts such as abstractions, which means that you have to code everything as is, as simple as it is, but it's really hard for people to understand. So with object-oriented programming, when they hide certain stuff through abstraction, it hides unnecessary stuff and it makes you understand what's there to understand, which is simple for the people to get like the concepts. It's very simple. So the languages like Java, C++, and Python have widespread adoptions, and understanding OOP concept is crucial for the effective software development in these languages. So most of these OOP languages, they are almost the same. They are the same. They have the same, the way people code. Like it might look a little bit different, like the keywords might be different, but it's almost the same concept. So when a person understands the OOP concept, the object-oriented programming concept, they will be fine while creating applications in Java, C#, Python, or C++. So let's move on. Console application, OOP. So this is like the basic application that you can create using object-oriented programming. And then in object-oriented programming in console application, it refers to a program that interacts with the user through a command line interface. So console applications typically read input from the user, perform some processing, and display output on the console. So that's how they work. Like if you look at the back in the days, we used to use like CMD or command line, whereby we just gave the program that we are using some information, the input that it's requiring us to input. It did calculations in the background and gave us back the results. That's a console application. And that's the most basic application that you can do when you are starting creating applications in programming in either Java, C#, C++, even C. So those types of applications don't have the user interface, which means they don't require you to create a design. It's just a bunch of commands that you have to create. So how it works is these certain concepts. You define classes to represent different entities or components of your console application. You might have a class to handle the user input, another class to perform calculations and process the data, and a class responsible for displaying the output on the console. So as you can see, there are different classes that are existing here. So for beginners, most of the beginners, they put each and everything in a single class, and it's going to be like super hard for a person to understand. But if you want your code clean, when you're designing your classes, you have to create multiple classes so that people can understand. So I'll go a little bit faster because I can see that the time is going. Encapsulation, it helps organize the code by bundling related data and methods within a class. So when we are putting classes, we are putting methods and variables, we are putting certain functions inside a class, we bundle them together. That is called encapsulation. So each class can encapsulate the logic specific to its responsibilities. If I want a class of students, in that class of students, I'm going to have a method which is going to be calculating the points of those students. Then I have to put it in a specific class with its own logic, which means that it has to be logically sane or logically specific to the responsibility of that class. So for instance, the class responsible for the user input would encapsulate the methods to read and validate the input from the console. So which means that we can put the class to gather, to do other things apart from these two things, because it wouldn't be logically specific or wouldn't be logically understandable to a person maybe that might want to read the code. Because most of the times when we are creating code, we have to think of other people that may read your code. Because when we move forward, you might find that you'll be working in teams whereby other people will have to read your code. So we have modularity. OOP encourages modularity by breaking down complex systems into smaller self-contained modules or classes. So each class focuses on a specific task or functionality, and this modular approach makes the application easier to understand and maintain. It's the same as encapsulation, but it's like reverse encapsulation. So we have a complex issue or a complex application. So we break it down into small classes or small systems. When we break it down, it's easier to understand and it's easier to find where We might have, like, let's say if we're having like errors in certain places, so we find them easier because it's already broken down. So we might know somewhere to look because uh, each system has a specific task. So separation of concern, following the principle of separation of concern, different classes handle different aspects of the application. For example, you might have separate classes for input handling, data processing, and output display. The separation allows you to have a better organization and reduce dependencies between parts of the application. So when we separate things, we know exactly how the data is being organized. If there is an error, we know where to find it. Inheritance and polymorphism. Inheritance can be used to create specialized classes that inherit common behaviors from a base class. So there are certain classes, like let's say I might have a school class whereby it has specific behaviors from a school, and then let's say a certain department, it might have like certain behaviors. Instead of creating multiple classes, I might inherit certain behaviors from that class and use them as in a child class or a subclass. So this separation allows you for better organization and reduces dependencies between the parts of the application. And then it also enables the code to to be reused, and it's flexible. It makes the code flexible, and it also helps in the flexibility in designing console applications. So the main application class in console, you will know there is a typical main class whereby we have a main method. And in that main method, that's where we initialize our objects. So when we initialize our objects, um, it's like that's why all the methods we've created in different classes, if you want them to work, we put them in the main class so that they can be initialized and the application can work. So, and then there is testing and debugging. It facilitates unit testing by isolating functionality within classes and allowing you to test each class independently. Debugging is also easier as you can focus on individual classes and their interaction. And I've been saying this all over all these other stuff such as inheritance and polymorphisms, we're separating things, modularity and encapsulation. So when things are separated, it's very easier to know where to find something specifically. So this is a sample code of app in a console app in C# and Java. So we have our main class here. Our main class is right here. We can see that we have the namespace. We have our main class, which is program, and then it has the main method. When I was talking about the initialization in the previous thing, whereby it allows you to test each class, you would typically a main class that serves as entry point of the application. This class initializes necessary objects and coordinates the flow of the program and interact with the user input output classes. If you look at this program created here, we are telling our program to write hello world, and this is our main class, and this is what we call the main method or main function. So in the main function, that's why we write something that the user is going to see, or we can read from the user what we want. So there is console write line, and it's going to write hello world, and then console read key for reading now something from the user. So, and then the first program here, it's a C# program, and I was trying to show you how different object-oriented programming languages are almost the same. If you look at our Java program, it also has the same code, because we have the main class, which is public class program, and here we have public class hello world, which can also be called program, because the name regardless is almost the same. And then we have public static void main, which is the main method, and then system.out.println hello world, and then we close with a semicolon. So here, instead of system.out.println, here we have console.writeLine. It's this different keywords, but it's the same concept. As we can see, we are inserting a string of characters, which is hello world, encapsulated in how do they call this, quotations, encapsulated in quotations, and then we can see the same here happening on the hello world of the JavaScript. I mean, the Java language. And then you can see that we are using the curly braces to open and closing the program, opening and closing classes, opening and closing, um, opening and closing the methods. But on different languages, you might find that the semicolon, they don't consider them, but with C# and Java and C++, it's really important to be ending each and everything with a semicolon if it's a method or there is parentheses. So let's explain what is happening here. So we start by declaring a namespace called hello world app, and then namespace provides a way to organize a group related code. Inside the namespace, we define a class called program. And this class contains the main method, which serves as an entry point of the program.cs. So we have the main method here, here in the class program, which was declared here. And then within the main method, now we use the console.writeLine statement to display the hello world message on the console, which is this one here. So finally, we use the console.read key to wait for a press key before the console window closes. This follows to see the output before the program terminates. So this means that here we are waiting for the user to do something before the program closes. If we don't put console.read key here, the program will just execute and close at the same time. So this one gives us the probability for the user to see what we've written and maybe allow him to press any key. When they press any key, because we are not asking for any input, it's going to terminate the application. So to run this code, you would typically create a new C# console application project in an integrated development environment or IDE like Visual Studio or Visual Studio Code. And then you can paste the same code in there, or you can just type it into the appropriate file, which is, as an example, program.cs, and then build and run the application. When executed, the program will display hello world on the console, and then you can exit the program by pressing any key, as I explained. So I don't know if we go for time, but this is the last slide. Let me go through it like really fast. So software development refers to the process of creating designs, so software development steps. So we have the requirements gathering, where we gather and analyze requirements depending on the software that we need to create. This involves understanding the needs of user stakeholders and defining the goals and objectives and documenting the functional and non-functional requirements. So in the design, we design, this is the design phase where developers create a blueprint of software systems. This includes designing the architecture, components, modules, and user interfaces. And it involves making decisions, the technologies, framework, and database that are going to be used. So in this way, we start understanding what program we're going to use, what IDE are we going to use, what language are we going to use. So implementation and coding, this is where now the developers start coding according to the design specification. They use programming languages, libraries, tools, and translate the design into functional softwares. The code is organized into modules, classes, and functions for better maintainability. Testing, after coding, we start testing what we've done. We can test in different ways. Like we can do it as test as a unit. We can test in as an integration. We can test the whole system, and we can do what we call acceptance testing with the users trying to see if the application now is ready to be used. So the bugs and issues are identified and reported to be fixed into this stage. So deployment, once the program has been tested, it's deployed through the production environment, and this involves preparing the software for installation and configuring it on the target system. It ensures all the necessary dependencies and infrastructure that are in place. Now, maintenance. After the deployment, the software enters the maintenance phase, and during this phase, the developers address issues, bugs, and makes improvements and enhancement based on user feedbacks. That's when you see that WhatsApp is continues to update. So they are maintaining the app. They find that there are certain things that don't work properly or certain things that can work even more better. And that's when maintenance phase comes in. Documentation and support throughout the document process. Documentation is created, provide instructions, guidelines. That's where the about page comes in. And additional ongoing support is provided to address user queries, troubleshoot issues, and provide assistance with the software. So it's an iterative and collaborative process, often following methodologies like Agile, it can be waterfall or spiral. It requires a combination of technical skills, project management, teamwork, attention to detail to deliver a high quality software that meets the needs of a user. And the last thing that I can say is there is no such thing as a clean or proper application that doesn't have any errors. Each application is going to be having errors. So that's the reason why there is always maintenance for it to be even more functional. And yeah, that was my presentation. Thanks, and I'd like to apologize for technical issues that happened at first. And I'm expecting some questions. If you guys have questions, please, you can ask right now.